Welcome to this session about Python, which will be presented by Jerome de Favereau from usefull.
Hi everyone. So today I will tell you a bit about the Python programming language. This tutorial is mostly targeting people who know already a bit how to program, but have never worked with Python yet. The idea is you've already programmed a bit in Fortran, in C, or anything else, and now you're considering Python, but you don't know what it is, and so I will try to help you decide. Oops, sorry, my slide is not moving. No, my slide are moving. Okay, so see if you want to use Python for some project. So what is Python? Python is a programming language which is object-oriented. Which means which is a paradigm of programming in itself, but we will not cover this today because it's very deep and broad. Python is an interpreted language, so it means that the program you will write will be interpreted line by line, not compiled as you would have in C and Fortran. It makes your program very portable because you just have to copy the Python file from one computer to the other, make sure that you have a Python installed on the machine with a proper version, and then you can just run everything, which is a huge advantage. But the downside is that usually the performance is lower with interpreted languages than with compiled languages. And there are many ways to make a Python performance better. There's a tutorial on that, if I remember well, but we will not cover that today. Python is a very high-level language, which means you have lots of high-level functions and modules which help you do things that would take a lot of time to code in a lower level language, like accessing website or database or making high-level computation and things like that. All that already exists in Python, you don't have to do it. And finally, Python is dynamically typed and strong typed, which means you don't have to explicitly state the type of a variable. We will see it in a minute. And it is still strong typed, which is different, for instance, from JavaScript, which means that the variable types are not changed automatically during the runtime, which is quite safe. And it's a good point for me. Okay, so why would you like to use Python now? What are the arguments? The Python was written with the idea that it should be easy to read and with a short syntax, short and simple syntax. That was one of the goals when Python was created in the 90s. So that's it. That makes it quite easy to learn too. Then the fact that it's an interpreted language makes it nice to try and play, because you can try a line, see what it does, edit a bit, try again, see, and so on, work iteratively, which is quite nice also to learn. But also when you have long lines, you can just put them one by one and see what it does and work step by step. Then you have some help in the interpreter, so you can ask for help on a module or an object, and then you will get full help, which is also very handy. And finally, one of the things that make Python very easy to learn is that the community is huge. Stack Overflow for Python is one of the top 3 biggest community, if I remember well. So you will always find help, whatever you want to do, which is really, really handy. So as I said, Python is a high-level language, which means that most of the time you will go straight to the point. If you have to make some heavy computation, produce some graphs and things like that, there are modules that do that. It will be short. That part you don't have to think really about it. What you will do is the algorithmics. You will think about what you want to do, and all the things around will be should be managed by already present modules. We won't have to reinvent the wheel most of the time. And finally, as I said on the previous slide, Python can be really fast if you use the proper modules, because some of the core modules of Python are written and compiled in C, which means that if you use the proper functions and modules and you use them well, most of the heavy lifting in computing will be fast. And on the other hand, Python itself can be made faster if you do it well. And overall, you can have good performance in Python, even though it's an interpreted language. So we'll start with some basics of syntax, just so you can start playing around. And for that, there are two solutions. Either you have Python installed on your personal computer and you can work there, obviously. On the other hand, if you want, you can also use our own Jupyter Hub server. You should see the address on the slide. This is a website where you can type your Python commands and execute them. You will have to log in there. So if you have CISM credentials, most likely some of the Louvain participants have, you can use them. And if you don't, you can request use the chat to request temporary credentials, and the credentials will be given to you. Once you have an access to this Jupyter Hub website, you log in, and then you can create a new notebook selecting the Python 3 kernel. And then you can enter the line that is shown on the slide, print hello world. And on this notebook, to execute a cell can contain as many lines as you want. You press Shift, then Enter, and you have executed your cell. If you work on your personal computer, obviously, you start the Python interpreter with the Python command, and then you enter the line print hello world and enter, and you will have executed your first line. So I will continue from now. If you arrive late and you want credentials, you can always ask in the chat. My colleagues will help you. Okay. So first, how to work with Python in general. The usual way that we won't basically use today, but that's the usual way when you work on your project would be to put your code in a file. Just name it with a .py suffix, and then you make it executable. And I can highlight. Oops, sorry, I did a wrong move. This is better. So you make it executable, and then you can run it with / if you're on Linux, name like .py, and it will run. Okay, so that's what that's how you usually work in Python. For this tutorial, either you will work in the interpreter on your computer, or you will work on Jupyter Hub, which works a bit like the interpreter, but you won't create files. Okay, so the basic syntax is assignment of variables, the first thing you always learn in programming. And I show a bit of different type of objects here. And you see I can have integer numbers, floating points. I can have strings, and strings are defined with single quotes or double quotes. And the only thing is that you have to put the same type of quote at the beginning or in the end. You see that there's no declaration of the type of the variables, as I said before, which means Python gets the type of the variables from the object itself and assigns the methods that will work on it directly. Okay, so that's one specificity of Python. And once you have defined one of these objects, you can ask for help with the help function here. So if you type help and then the name of the variable you have here, or help with str, which is the object for string, then you will get the full help in Python for the object you have put in between the parentheses. Okay, to tell you everything you can do with it with some text help. In the same way, you have the dir function that will tell you the list of available methods. For instance, if you have a string, you have the upper method, which will make the string in uppercase, for instance. Okay. And then if you just type the name of a variable in Python, then it will immediately show you, and you tap enter if you are on your computer, or shift enter on Jupyter Hub, you will immediately get the content of this variable. Okay. Now, let's see if I get nothing here. Okay, good. So for instance, here, if I run the help on the string object, I get a very long help telling me first things that special things. Then you have capitalize, you have format things, checking if it's a decimal number and things like that. Okay, you have the whole help for this object, which is huge for strings because you can do a million things with strings just by typing help and the name of the object. Obviously, you can also get help on the Python tutorials and documentation on the web. The official documentation is fantastic. The official tutorial is good too for starters because it covers all the good features and all the pitfalls you can fall. Then now we've seen the basic objects. Another type of objects are the list objects, which are quite at the basics of many algorithmics in Python. And these lists are ordered and they can contain many different objects. They are not limited to one type of object, so they are heterogeneous. For instance, you have a list here, my list, which contains two numbers, 1 and 3, then a character A, then another list which contains 2 and 3. Okay, so it's a list with numbers, characters, and another list. And then if you want to access an element, you use the brackets syntax. And then I get the second element of the list, which is the third element of the list because it starts at 0, sorry. And it will be the A that's here. And then you can also get elements from the other hand. If you put a minus between the index, you access elements from the right hand instead of the left hand. So my list with -1 on the between brackets is the last element of the list. Okay. And then you can also use slicing, which means you take elements from 1 to 3 excluded. So the right boundary is always excluded. Okay. So this is element 1 and 2, meaning the 3 and the A. And in this slicing, you can also use the negative indexes. For instance, if I put -1 instead of the 3, I get all elements except the last one. And I can put -2, I can put minus index at both positions, and so on and so forth. Okay, so slicing is very powerful and quite intuitive. The only thing you have to remember is that the element on the right is always excluded. Is everything excluding the last element on the right. The other bread and butter of Python in terms of objects is the dictionary. So dictionaries are heterogeneous too, but there are lists of key and values. So you have always a key associated to some value. Here you have an example. The key 1 is associated to value tests between quotes. And the key 2 as a character is associated to the value 4, and the key 4 as a number this time is associated to the value, the list 1, 2. Okay, so you have keys and values. When you want to access one key, you use the brackets again, and you give the name of the key. And this is extremely fast. It doesn't depend in principle of on the size of the dictionary, except for very big and ill-defined dictionaries. So this is a very efficient way to store data. And last thing is that obviously if you request a key that doesn't exist, for instance, on the example below, I ask the key 4 as a character and there's no key interrupted. Okay, no, nothing. So if I use the key 4, but as a character and not as a number, Python will not convert this character to a number because it's strongly typed. And so it will return an error saying key error 4. There's no key called 4 as a character. You see it by the quotes in my dictionary. Okay, so those lists and dictionaries are really the most important structures in Python. They are the most used and they have big advantages in terms of speed and etc. Okay. So now the other thing that you always see in a programming tutorial are flow control. Obviously, for instance, an if block. In Python, you see a typical if block here. You have the keyword if, simple, then the condition, test greater than 0, then a colon. And in Python, the colon is always the indicator of the beginning of a block. And then the block is defined by a series of lines which are indented, so pushed to the right by convention 4 spaces. It's not mandatory, but you should. And then the block is defined by all these lines that are indented. When you stop indenting and you go back to the left, then you are out of the block. This is a choice of Python, not using brackets and things like that to define blocks, which makes the code readable because blocks are always aligned, and so you know where you are in the block or outside of the block. Okay. In this case, if the test variable's content is greater than 0, then we print it is bigger than 0, and the else condition says what to do if the condition is not respected, and then we print it's 0 or lower. Okay. On the condition test greater than 0, you could add other conditionals with the and, or, and not keywords. You see in Python, as a different from other languages, we use the English words and, or, and not to make it more readable. We could put here, if not test greater than 0. That's quite readable, and you don't have to do special symbols or anything. It's simple. Okay. Then another and one of the most used block flow control in Python is the for loop. The for loop in Python works like that. You have a for keyword, and then you define the thing on which you want to loop. Here, the animals list that we defined above. So we have an animals list which contains dog, python, and cat, and we make a for loop on the animals list, and we assign one by one all the values of the animal list on the animal variable. And then inside the loop, you see we are inside the loop because there is this indentation. Inside the loop, you have the animal variable, which is first dog, then python, then cat. If the length of the animal, so len is a function in Python that tells you how many characters basically there are in a string, or how many elements there are in a list or in a dictionary. It works with many things. If the length is greater than 3, it prints the animal, and then it adds that's a long animal. Otherwise, just prints the animal. Okay, so if I execute that, I get first dog, then python, and with python I have this additional string that comes because the length of the animal is more than 3. On the contrary, opposite with dogs and cat, and then cat as the last one. Okay, so it's a very short syntax and efficient. You have a for loop on a list and on many other objects, because you can do for loops on many things on Python. And each time it will take the one element and put it in a variable that will be used inside the block. Okay. That's a for loop, one of the most important loops in Python. So there are a few other things about for loops that I want to add. For instance, if you're used to C++, for instance, you are used to doing for loops on objects and having the index of each object. Okay. Here, if you use the system we saw just before, you see that there was no index, you just got the variables. If you want the index, it happens a lot, then you can use the enumerate function on the animals list, and then the for loop will return the animal, but also the index of the animal. So if I execute that now, I get animal 0 is dog, animal 1 is cat, animal 2 is T-Rex. You see in my string, it put the index and then the animal. This syntax of string formatting, I will explain later. But you see here, you got the index and the value at the same time. And then you can also loop on dictionaries. For instance, here I have a dictionary with the key first is the value Monday, second Tuesday, third Wednesday, beginning of the week. And here I use a for loop on my dictionary, mydict.items. And this .items method will allow to return the key and the value at the same time for each key value pair. So if I do that, I get the first day is Monday, the second day is Tuesday, the third day is Wednesday. If I would have removed the .items part here, then the for loop would have been just on the keys. That's the default. If I want keys and values, then I can use .items. There are other flow control statements that are a bit less used, but still useful. The while statement that you probably already used in many other languages, that you probably use in other languages, which works exactly as anywhere else. While b lower than 100, print b, and then we do some tricks on the variables a and b. We replace a by b by a plus b. That's called multiple assignment. You see, we have two variables on the left, two variables on the right. I will come to that in the more advanced part of this tutorial. But then, if you execute that, you get the Fibonacci sequence while the b is lower than 100. So the loop stops when b is higher than 100. Okay, simple loops just until some condition is broken. And then you have two statements that are useful also for loops. The break command, which gets you out of the current block, of the current loop, and the continue, which when you get there, skips the rest of the block and gets to the next step of the loop. Okay, so you put a continue in the middle of a block, and everything below will be removed, and you will get to the next iteration. Oops, sorry, trying to follow. Okay, everything's right. Okay, then another basics of syntax in all language is the definition of functions. So here you have a function defined in Python with the keyword def, then the name of the function, then between parentheses, the arguments of the function, and the usual column to define that you will start a block. Okay. Here you see in functions a few things. I have three arguments, and you see arg2 and arg3 have a default value. So if I put equals 0, it means that if this argument is not specified, the value will be 0. Okay, that you guessed quite easily. Then if I execute this, you see that my output is the result of the function with the arguments a string and arg3 equals 7. So my output will be filled by the return statement above. Return statement means what is on right of the return statement will be put in the variables on the left when I call the function. Okay. And then you see in the arguments, I specify first argument a string that will be put in arg1 above. And then I don't give anything for arg2, then it will use the default. And then I give arg3 equals 7. Okay. So it shows you that in Python, you don't have to keep the order of the arguments. It's not important, only if they have default values, obviously. If there's no default value, then you don't know. But if you have default values, and you can specify, you cannot omit arguments that don't have a default value. That's a better way of saying it. And then if you have default values, and then you can omit them, and then you can also specify arguments using their names to specify them in the order that suits you best. Okay, so that's different from the very precise signature of functions, for instance, in C. Okay, in Python, the order of arguments is not important, providing that you give their names so that Python knows who goes where. Also, you always have to give first the arguments where you don't give the name, and then the arguments where you give the name. That order is mandatory. Okay. So as it's written on the slide, you can call arguments by position, like the A string on the left, or by name, like by putting R3 equals 7 like you have on the right. Okay, there's a lot of information there. I know. Okay, so now I told you we would discuss a bit about string formatting, and we will start by the really basic things. For instance, the plus operator allows you to gather two strings, like you define this my string with hello plus world, and obviously it builds the hello world string. Okay, that's the simplest. One other useful one is the join method that you have here. Join takes a list of strings as an argument, and it is applied on a string that will be used to glue the parts together. So this will take all the elements and will put a plus sign that I take here between every element. So I will get this. So you have cat plus dog plus Python. It is typically used, for instance, to make a comma-separated list and things like that. Okay. And then if you want to process text, which is very classic, for instance, if you have a website and you take things from a website or from a text file, you have the strip function, which removes spaces and new lines on the left and right of the string. And then you have the split function that will split a string between its different words by default, which means it will split on a space, single or multiple spaces. Okay. Then you see my sentence started as a string, cats like mice with a new line. I stripped, so I removed the space on the left and right and the new line. Then I split it and I assigned to the variable my sentence, which is now a list. And then I print the list that contains now the words cats like mice. Okay, I see a question. Somebody is asking which file I am running. The file I'm running now is my presentation. It's not, so you have, you don't see the font. I can make the font larger. That's something I can do. That's already something. Like this, or even like this. I hope you see better. So the file that you have here, I'm not running it. You see the exact thing you have on the PDF on the Indico website. You can copy and paste text from there. I can also put the Python file on the website during the break or after the presentation if you want to execute cells by yourself. But I think it's more interesting if you type commands yourself, just to get because if you just copy and paste them, then you don't really understand what you're doing. So I prefer that you type the commands that you want to understand better. And if you have to come back later, you come back later. But I will put the full presentation on the Indico later, so that you can execute the notebook in Jupyter Hub, for instance. I hope the font is large enough now. If it's not large enough, I can I cannot go a lot further than that. If it's still too small, don't hesitate to read on the PDF at the same time if there's something you cannot read. Okay. So a bit more about strings. When you want to make some nice text, the usual is to use templating. For instance, if you are making a website, there's a really nice web framework that's called Django, which does websites in Python. You usually use string templating, which means you write a text like the is here, and then you put holes in where you want to put the words. That way, if you have to call for instance, a web page with the name of the current user, then you can simply reuse the same template by changing the name with that. So if I do that, you see I use my string as a template. I use the format method, and then I use two arguments, cat and happy. and they will be put in the same order in the holes that I've put with the brackets here. Okay, so that's nice, but you have to put the things in the same order, which is quite annoying. So the better syntax is to use the name of the arguments in the template. So here I redefine my string with the animal is status, really status. And then when I call the format method, then I give the argument name. So animal will be cat and status will be happy. And then in the template, each occurrence of animal will be replaced by cat, and each occurrence of status will be replaced by happy. And you see it works, and it allows you to use the same variable 2 times without having to specify it 2 times in the arguments, and it doesn't depend on the order, which is quite nice too. So, and if you have the values you want to put into the template in a dictionary, then there's a magic way of doing it. I will come back to that later on a specific slide. But if you give a dictionary to a function and you put 2 stars in front, like star star my dict here, then it will turn your dictionary into a list of named arguments. So it will replace this dictionary by animal equals cat and status equals happy, exactly as we had here. And then you see you get your data as a dictionary, for instance, for a JSON file, and then you can format your string directly using that without specifying the arguments one by one. And it works still very well. Finally, since Python 3.6, you can also use what is called f-strings. And then it looks like the syntax for the format. You see, we have variables with names in the template, but you have an f in front of the string, of the template string, and you don't have the format. What is done with f-string is that the variables are directly replaced by the value inside the f-string. So here I don't have to specify format. Since animal and status have already been defined, the f-string will work immediately. This is very efficient. It is quite fast too. So in most cases, this is now, since Python 3.6, the way to template strings. And another advantage of f-strings is that you can use codes inside the template. Like here, I multiply one of the strings by 3, and here I put it uppercase, which means that I will get some really silly looking output, but at least you see it works. The word happy has been written 3 times first, and then the second time it has been put uppercase since I use the upper method here. Okay, so now you have a lot of knowledge about string formatting, which is quite an important topic. And to finish with that, I will just tell you that you can use some centering, alignment, and things like that, and number formats to reduce the number of decimals. For instance, here I put 3 strings with different alignment. So you see in the template, I have a column which tells you what is left on the column is usually the name of the same name of the variable. What is right on the variable is the format options. So here I put a hat then 30, which means center it on a 30 block of characters. I use the format method here, but you can also do it with f-strings. Okay. And the second line means right align, and the third line means left align. That's quite intuitive. For numbers, then you have a similar syntax. I use the column again. And then, for instance, here, .2f means the f is for float. .2 means 2 characters after the dot. And on the third line, 06.2f means 2 characters after the column. 6 characters in total, and fill the rest with zeros. So you get the first one is the full number I put. Second one is limited to 2 characters. It's not rounded. It's just limited to 2 characters for display. Okay. And the third one is 6 characters in total, including the dot and filling with 0. I can also fill with void, if I remember well. That works well. You see, I remove the 0 and then it just puts empty space there. Okay. So now you really have our masters of string formatting in Python. The last thing I wanted to tell you is that there is a legacy way of string formatting that you have on the bottom of this slide. You will see it, especially in Python 2, a lot of places, but you shouldn't use it because it's far less efficient than new ways. But as you will see it in all the code, I wanted to show you because you have to know what it does. So with this, you know all the basics of the Python syntax. But obviously it's a bit lacking, so I want to go further with you. And so we will discuss how to go further now. One thing that I wanted to tell you is that, so if you work on your computer, you have the Python interpreter. If you want to have something a bit better, you have the IPython shell, which is another layer above the Python interpreter, which gives you nice goodies like tab completion, some history, some more advanced help, some magic functions with the % prefix, and so on and so forth. All those things are also included in I'm not sure all, but most of them at least. Tab completion, yes. History, obviously, and magic functions. All these things exist also in Jupyter. So if you are working on the website, you can use most of these things to make your life easier. Okay. So I told you about these double star things that we saw for the format. So there are 2 ways of that. If you have a list called myList here that contains dog and cat, then if you call a function with star myList, it will replace the inside of the parentheses with a list of arguments, dog, then cat. So if you just put myList without the star, there will be only one argument to my func, which will be myList, and it will be a list with dog and cat. If you put a star, there will be 2 arguments now. The first will be being dog, the second being cat. Okay, arguments by position, so you don't have the name of the arguments in front. With a dictionary, you put 2 stars then, and then it turns the dictionary into a list of named arguments. So here you will have the first argument with the name animal and the value dog, and the second animal with the name toy and the value ball. Okay. So that way you turn a dictionary or a list into a list of arguments. As I told you before, arguments by position, so without names, should always come first, and then arguments with names should come next. So you can define functions with arbitrary arguments like this. You first type star args, then star kw, so keywords arguments, and then when you call your functions, it will put all the position arguments in the first list args, and then it will put all the named arguments in the dictionary kw args. So if I call my function that I define here that just prints the values of these 2 things, if I call this function with the arguments pos arg1 34 and then 1 named arguments which we call named, then I see that the args list contains 2 things. It's not a list, it's a tuple, it's a different kind of list which is just not editable, which are the 2 positional arguments, pos arg1 and 34. And then the kw args is a dictionary as expected, which contains just 1 key and 1 value. The key is the name of the argument, named arg, and the value is named. Okay. So you see, using this technique, so these star things work in 2 ways. They turn lists, as shown here above, lists and dictionaries into lists of arguments, but as shown here, they also turn lists of arguments into lists and dictionaries if they are used as in the function definition. So if you use them in the function call, they turn the list into a list of arguments. If you use them in the function definition, they do the other way around. They turn a list of arguments into a list that you can use inside the function. And that allows you to define functions in Python with an arbitrary number of arguments. For instance, the print function that we've used many times now, you see here it used two arguments, the args string and then the args object here with a column. So there are really two different arguments. And that's how print is defined with an arbitrary number of arguments, okay? So that's quite convenient to be able in Python to define functions with an arbitrary number of arguments. So another very important part of Python, which makes life easy, is list comprehensions. List comprehensions are lists built using a for loop in a one-liner. So here I show you an example. So I do a for loop for x in range 10. Range is a special function in Python which gives all the elements from 0 to the number that's put there, or from, if you put two arguments, then it starts at the first. So here it will build a list. So it will loop on x on numbers from 0 to 9, and it will immediately build a list of x squared. So this line builds the list 0, 1, 4, 9, 16, etc. directly in one line. Okay, that's quite convenient, but that's only the start of it, because you can also use an if in the list comprehension. For instance, is here I have a list of beasts which contains cat, dog, and python as usual. I do a for loop for beast in beasts here, as we've seen before. So it takes every element of the beasts and put each one by one into the beast variable. Here it puts the beast uppercase, but it does all that only if the length of the beast is smaller than 4. Okay, so it will loop and it will do this upper method, but only if the length is smaller than 4. So if I do that now, I get only cat and dog because Python was filtered out by this, and every other element has the upper method applied on it. Okay, so this is quite convenient. You have a filter and some mapping, it's called, which means you apply a function on each element. Then another very useful part that you can use with list comprehension is the zip method. The zip method takes multiple objects or lists, and it runs on them one by one, but on all at the same time. So here I have a list called beasts that you know already, and I have a list called toys, and I would like to loop on them, but first taking cat and ball, then dog and frisbee, then python and dead animal. Okay, and for that I use the zip function here, and I zip beasts and toys. Okay, it works like that. So zip beasts and toys will return one by one the first element, then the second element, and the third element of both lists at the same time, and it will assign them to the two variables a and b here. And then what I do is I take my template here and I run the format method with the arguments a and b. So it will first put a to cat and b to ball, then a to dog and b to frisbee, then a to python and b to dead animal. And this thing will then be a list containing these strings, but with the one by one the content of the two lists. So the list that I build with this list comprehension first contains the cat plays with ball, the dog plays with frisbee, and the python plays with a dead animal, as we expected. Okay. So another thing with list comprehension that you can do is you can. So we've seen that you can have an if after the for loop. You can also have an if before the for loop, which is a syntax that you have in Python that you can generally have, which is a ternary operator, which means you put this if some condition, otherwise you put this. Okay, so here it will put x squared in the list if x modulo 3 is different from 0, which means if x is not divisible by 0, otherwise it will just put x. So the result is that every one of these numbers that is not divisible by 3 will be put to the squared, but the numbers that are divisible by 3, like 3 here, 6, and 9, are kept as x. Okay, so here I put, it's another type. I wanted to show them separately because you had this filter on the right, and then you have this else clause system on the left, which allows you to do two different things depending on the value of a condition. And finally, we've seen list comprehension, and you also have dict comprehensions, which allows you to build dictionaries from this kind of syntax. So here you have a for loop. Again, is on this range 10, so it will go to 0 to 9. And then it puts the keys to x, so 0 to 9, and then the values to x squared minus 1. So here I will have a dictionary with 10 keys, 0 to 9, and the values will each time be the value of the key squared minus 1. So we will have this dictionary, and you can easily check that it does what I told you it would do. Okay. So I think it's time for you to take a few minutes to try to see if you really understood what we did on list comprehension and things like that. So I give you the following exercise. I will let you work on it a few minutes, and then I will show you the solution for that. So we have a list which contains 3 lists. The first 1, 2, 3, 4, 5. Second A, B, C, D, E, and the third will be range 5, which contains 0, 1, 2, 3, 4. Okay, each time is each of them is 5 elements, and they are defined as this. And we would like to have a list comprehension that turns this list of lists into another list of lists, which contains 10A, 21B, etc., etc. So it's a list that contains first the first element of the tree, then the second element of the tree, then the third element of the tree, but not in the order they are written here. First, the 1 comes from here, then the 0 comes from the range tree, then the A comes from the second. Okay? So this is a small exercise on list comprehension to check that you've understood the last 4 or 5 slides, and also the basics that we saw before. Okay, I can let you work a bit on that, and then I will show a solution in a few minutes. Okay, so let's work on this together. It will be mostly me, obviously. Let's see. So here I have a block of code to work with you. So I define this list of lists just to make it shorter. And then we want to use a list comprehension. So first we will put brackets. And then we want to build the lists of lists. So it will be something like that. For A, B, C in something that I don't know what it is. Okay, I want a list of lists, and each list has 3 elements. And the 3 element will be not in the order A, B, C, but A, C, B. Okay, I create a list of element A, C, B from 3 variable A, B, C in something. What is this something that I want to build? It's this A, B, C will come one from each of the 3 elements of the list lol. So it will be, as we just saw, using the zip function, it will be lol 0, lol 1, and lol 2. Okay, so this should give us the right solution. 10A, 121B, etc., etc. But you see, this zip uses 3 elements, 3 arguments, which are each a part of a list. Okay, it's the first, the second, and the third element of a list. We saw just before that we can turn a list into a list of arguments by using the star syntax. So I use a star, which turns this lol into 3 arguments, the first being 1, 2, 3, 4, 5, the second being A, B, C, D, E, and the third being range 5. And when I do that, I get exactly what we expect, the solution. So you see, the only thing we had to do is first zip the 3 arguments to run them one by one on the 3 lists at the same time, and then change the order here to get directly the thing that we wanted there. Okay. Then I will put that to help you. So I keep this. And the other part of the question was, if we want to keep them in the same order, what can we do? Then you see that the part that we have on the left, ACB for ABC, is not needed because we don't need to change the order. So we can just do zip a list of zip of star lol, and it will zip and then turn what we get into a list. So it will just transform the ABC into a list. Oops, sorry, I made a mistake. What is this mistake? Sorry. Okay, anyway, I wanted a list, so I'm not good with runtime exercises. So what we want is A for A. Up. So yeah, so if I do that, you see, I get 1A0, 2B1, 3C2, etc., etc. You see, those are not lists exactly. Those are tuples because zip returns a tuple of ABC, which allows us, in fact, to use them separately. If we want lists, I don't know why it doesn't want to do that, but if I do that there, perhaps, no, it's not happy. Okay, it's a Python version issue, sorry. It doesn't work the same in all versions, but you get the game. So the first one, if we want to change the order, we use zip and then we change the order there. If we don't want to change the order, we take the output of zip directly and we put it into the list. Okay. Okay, so that was that for the exercise. If there's something you didn't understand, don't hesitate to talk on the chat. And then I will go on with some other topics on Python, starting with how you read files in Python. Okay, so the basic way to read files in Python is to use the open function on the path of the file you want to open, and it creates an object which is called a file descriptor, which links to the file. So if you want to read one line of your text file, you can use the readLine method on the f object, and it will return the first line of the object. If you use it again, it will return the next line. If you want to turn the whole file into a list of lines, you can use readLines, and it will take the whole okay, I got a suggestion in the chat. Yeah, but the suggestion I got in the chat depends on the Python version. That's the problem I had. That's only it. The Python version I have on this computer, which is not my usual computer, is not the one I usually use. That's the only reason. But you're right, it works on most versions. Okay, so here I was readlines. So readlines take the whole file if it's a text file with line by line, and then it puts each line into a string and it makes a list of strings. But that's not the way we usually work with files in Python. First, we use the with keyword to open a new block in which f is defined as openhouses.csv. So in this with block, the f is defined properly. Okay, it's called a context manager, and it has some properties. The first one being that when you are in the context, f is properly defined. Another one is when you are out of the block, the file is properly closed, because in Python, when you create a file, you should close it properly. This does it automatically. And then you see another nice feature is that I can do for line in f. So I can use a for loop on the file descriptor object, and it will return each line and put them one by one into the line variable. Okay, and here I will, if I have access to this file, I will print this file. So it was a CSV file with some data, and it will print one by one all the lines of the file. Okay. So 3 things to remember: context manager with the with keywords that opens the file and closes it when you are out of the block. And then the for loop on the file descriptor f, which allows you to loop on the file one object at a time. Okay, one line at a time in that case. So now I will come to what I really like in Python, my favorite Python tricks. One of the first is the in keyword. So here you see if cat in my string. The in checks if what is on the left is contained in what is on the right. If on the right you have a string, it will check if the sequence of characters you have on the left is contained in the string. So if I do that, it will say that it found the word cat in the string my_string. It works on lists on the same way. You can check if the number 8 is contained in my list. Okay, it will check all elements. Obviously, it can be long, and return if it found the number 8. It also works on dictionaries. So if I have a dictionary with cat as a key with the value ball and dog with the value bone, it will check if Python is in the keys of the dictionaries. Okay. On contrary to lists, it is really fast because it doesn't check all the. It doesn't have to check all the keys. It just try to access the key and see if it is there. So for list, this in keyword depends on the length of the list. For dictionaries, it barely depends on it. It's really fast. Okay. In this case, the words Python, the key Python doesn't exist in my dictionary, so it will not print anything because I asked him to print found only if the Python was in it. Okay. So this is why my first trick is the in keyword. It's very useful. Another one is that in Python, most things are either true or false. For instance, a list is true unless it is empty, in which case it is false. So I can do if my list, it will I will enter the block only if the list is not empty. Okay. For a string, if the string is not empty, it's the same. So in general, if you have lists, strings, dictionaries, tuples, and other structures, if it's empty, it will be considered false. If it's not empty, it will be considered true, even if it contains the word false, for instance. Another thing that I like that we've already seen once in the list comprehensions is the ternary operator. So I will assign a variable myvar, the value dog if test is greater than 15. Otherwise, I will put the value cat. So here, test is 10, so it's lower than 15, so my var should contain the value cat. Okay, so it's called a ternary operator because you have one value, one condition, and one value. And so you have three arguments. And you see the syntax is Python is quite readable because it affects the value dog if something, else it affects something else. It's the same syntax we've seen in the list comprehension with the if on the left when we worked with the x squared, for instance. Okay. So another really useful feature is the get method. So if you have a dictionary and then you use the get method, you will get the value of the key that you give in the first argument. Okay, on that it's exactly the same as using the brackets to get the value of a key. But get has the additional advantage that if the key doesn't exist, and you've seen what happens if it's the case, you get an error, you get a default value instead of the error. So if I go mydict.get Python, you see that the only keys are cat and dog. Then instead of giving an error, it will give me the default toy, which is default toy. Okay? So that's very useful when you work with dictionaries. And for instance, only some keys are defined and the rest are not. Then you can use get for all the keys that are not defined. Then one other very important trick is the multiple assignment. So if here I have two variables, a to Python b.dog, I can do ab equals b cat. It will first evaluate what is on the right, so I will have dog and cat, and then assign these things to the left-hand side. So cat will be we go to B, and dog will go to A. Okay. So it's very useful. For instance, if you want to swap variables in other languages, you have to use a temporary variable. In Python, you can just swap using that, or for instance, for the Fibonacci method that we saw a bit earlier, then you can just do AB equals BA plus B, and it works directly. Okay. On the backplane, it works with tuples that we've already seen, that are objects separated by commas, but you see it's quite readable and intuitive. And using this, you can also make functions that return multiple values. So here I define my function that returns cat and dog. And then I can do var a, var b equals my function, and it will put cat into var a and dog into var b. Okay, and then if I print that, you guessed it, you have cat and dog. Then few things on lists, because lists are really at the center of Python algorithmics. You have a function which is called reversed, which allows you to do a for loop on a list, but from right to left instead of left to right. Okay, so that's quite easy. That's quite intuitive. And you also have a sorted, which will first sort your list and then do a for loop on the list, on the sorted list. So the sort obviously depends on the type of object you have on your list. If it's heterogeneous, it could be quite unpredictable. But for instance, here I have strings, and the sorting will just be an alphabetical sort. So if I do that, the reversed will be Python cat dog, and the sorted will be alphabetic, so cat, dog, and Python. Okay, and obviously you can reverse sort and sort reverse. You can reverse the sort by using the reversed function on the sorted list. Okay, and then see if you want to sort another way than the default, because here it's alphabetical, but you could do whatever you want. There's also a key other argument to sort it, which allows you to sort the way you like. But I will let you have a look at the documentation for that, because if you want to do advanced things, it will require more thinking. Okay, and then here for list, you also have these two things that I like quite a lot, which are any and all. So any uses the fact that all objects in Python are true or false, and it will return true if any of the objects in the list is true. So here I have a list cat, dog, 0, 6, and according to what we saw earlier, cat, dog, and 6 are true. So any of this list is true. On the other hand, all returns true only if all the elements of the list are true. In this case, 0 is considered false, so it will return false. Okay. So it can tell you easily properties of the whole list without having to run through them or using a list comprehension or things like that. Okay. So now that I have gone through all my favorite tricks in Python, we will dive a bit more into the inner workings of Python and how variables work. One quite counterintuitive way is that Python's variables are all references. If you work with other languages, it's not how it works usually. So for instance, in that case, if I define a list A, which is 1, 2, 3, and then I do B equals A, I assign the variable B to A. In fact, what I do is doing A equals 1, 2, 3 makes a reference. So A is a reference to a memory object, which is this list containing 1, 2, 3. When I do B equals A, I define a new reference to the same object. The 1, 2, 3 list is one object in memory with two labels that point there, okay? Which means if I do A1 equals 5, so I affect 5 to the first element of this list A, and so because B points to the same element in memory, B will be modified too. So here, I do A equals 1, 2, 3, B equals A1 equals 5, so the element 1 equals 5, I get 1, 5, 3. Okay, A and B are both modified because they are the same object. Okay, that's quite important to remember. But this is true only if you within certain boundaries. For instance, here, if I define A equals 1, 2, B equals A, if I do A equals 3, 4, I create a new label to a new label A to another object in memory, 3, 4. So if you understood exactly what I did before on the previous slide, this makes sense. It's quite intuitive. But it's important, it's an important example to show you how it works. Because when I do A equals 3, 4, there, I create a new label A to another object. So B points to the old object 1, 2. It hasn't changed, but the new A is a new label to a new object 3, 4. Okay? So in this case, if I modify B after all or A, it won't affect both. It will just affect the variable that points to the object in memory. Okay. Usually we say that assignment using the equal sign creates new labels. So if you have this reference thing that we discussed before and you assign objects, then you will most likely break this reference to the same object. Okay. And then it creates some, sorry, I have a weird things, but it's okay. So it will create some special effects. I won't go deep into it, but it's quite important that you know that it works like that. For instance, if you have a Python function, which takes a list as argument. Here you have def myfunc, which takes a list. And what I do is I take my list 0 and I put it to 3. Arguments of functions in Python are assigned in the same way as we saw before when we do B equals A. Okay, so arguments are references to the object in the same way. So if I define a list 0, 1, 2, and then I run the function myfunc on my list, then my list will be passed there. So it will be the same object here, and then when I will take the element 0 and put it to 3, I will have modified the my list without so inside the function. Okay, so that's what you would expect if elements are passed as reference, as we saw before. But you have to be careful, because in this case below, if I do my list equals my list plus 3, here I create a new variable my list, the same way as on the previous slides I created a new variable B. And this new variable my list will contain the content of my list, the argument, plus 3. So it will extend by something, okay? But this variable my list is only a variable inside this function. It's not a global variable of Python. It's just defined inside the function, which means that this my list has nothing, is not related to this one from this line on. This assignment here, as we saw before, breaks the reference to the object. And in this case, if I execute that, you will see that the my list that we had here, that I tried to add a tree on this, has not been modified. Okay. So these are examples. I don't expect you to understand them perfectly now, but when you will work with Python, these kind of things, you could have issues with that, and I want you to have in somewhere in your mind the idea that it could not work because of that, or it could work in a way that you didn't expect. I see I've got a comment, so I will click on it. Okay, no, I had a comment, but it doesn't. Okay, no problem. Sorry. So okay, so as I said, don't try to. You can try to get it completely understood. From what I explained, you have the most of the elements, but I just want you to be sure to know that arguments are passed by reference in Python functions, and so it can have adverse effects, and you have to understand these effects in order not to have bad surprises when you code. Okay, because this is not how it works in other languages most of the time. In C, for instance, you can pass references and copies. You can decide which one you do. In Python, there are ways to do that probably, but most of the time it's always reference. So now a very important part. I told you at the very beginning of this presentation that Python was a very high-level language and that it could do many different things that are already pre-coded inside it. That's not completely true. When you install Python, you have a set of functions that are already present, but you don't have everything. If you want to connect to a MySQL database, for instance, it's not included in the base Python. Python cannot contain everything. But be it inside or outside of Python, everything that you want to use that is not the basics of Python is used as modules. A module is just like a library you would have in another language. It's something that you use the word import on. When I do import CSV, I import the CSV module inside my Python code, which allows me to use the function of the CSV module inside my code. Then I can do, for instance, help on csv.reader, reader being a function, an object in the CSV module. Okay, here you see this dot syntax, which in this case means that CSV is a namespace, so it's a module which contains a set of functions, and I take the reader function or object from the CSV module. Okay, if I just need the reader object, I could do from CSV import reader, and then you see I can do help on the reader object because then it's directly imported into my program without the CSV namespace that we saw here. When you do that, you just want to be careful not to redefine something else as reader, because then you would overwrite this reader object. Okay. In this case, the risk is non-existent because you have the CSV namespace in front, which allows you to be protected from that error. And then one syntax that exists but is quite frowned upon is to use from CSV import star, which means you import whatever is in the CSV module inside your program. It's dangerous because it could import things. It imports things that you don't know what they are. And it's not dangerous on a security level, obviously, but it's dangerous on a coding level, because it means if you use the SQRT, so square root of math, and if by a stroke of luck this CSV module contains something that's called SQRT, then inside your code you don't know which one you are using, because you don't know that in CSV you had a SQRT function. Okay, there's no SQRT function in CSV, it's just an example. So usually you don't do this star thing. You use this syntax oops, sorry, I double clicked. Use this syntax above. Ah, come on. And you import just the things you need, and then that way you are sure to have exactly what you need, and you don't have things that you don't know what they are just imported inside your system. Okay. So here I will show you a small example of this CSV module, because we will use it in the exercises later. So CSV module is one of the modules that are distributed with Python. So you don't have to install anything. It's already there on your computer or in the Jupyter Hub. And what it does, some of you already guessed it, is that it's there to read CSV files. CSV files are text files containing data in columns, so a bit like an Excel file. You have a column title or not, it's not mandatory. And then you have various columns containing data as text or numbers, separated by usually a comma, for instance. Okay, so this works as this. So I do a with open my file as CSV file. So I use the file context manager that we saw earlier, and then I create a reader object from the csv.dictReader function of the CSV module on the file descriptor CSV file that I created above. And this reader is an object I can do a for loop on. And what it will do is for each line in my CSV file, it will put the line into a dictionary, and the keys of the dictionary will be taken from the first line, which contains the heads of the columns, and the values will be the value of the various lines. So if I do that, you will see that the first row contains a dictionary with the animal key and the value dog, and the toy key and the value bone. Okay, and then I had some template with that, and then the second one is animal. The animal key contains cat, and the toy key contains bone. Okay, so it will read a file, and it will create a dictionary with each line with the keys and the keys from the heads and the values from the line. Okay. So it's a quite nice way to read data files. I use it a lot in my work. And it's quite an example of how you use a module in Python. So you see, I first import the CSV module, and then I use the csv.dictReader function from this module to create an object that helps me read the files. I see I have a comment. Okay, I see it was about CSV, and the answer my colleague gave you is good enough. So the question was, what's the difference between import CSV and from CSV import star? And the difference stands in the fact that if you do import CSV, you have your object in that you can use in CSV dot something. While on the other hand, for instance, you have csv.dictReader, as we just saw. And if you do from CSV import star, you would have the object called dictReader and not csv.dictReader. So it's not the same thing. The danger I thought about, it comes from this difference. And if you want a complete answer, you can follow the link my colleague gave you. It's quite complete, I guess, knowing the colleague. Okay, so this was a small example of how to use a CSV module, and any module, in fact. So let's continue with this module on the write mode. So in this case, I also import the CSV module. I open it with the CSV, with the context manager, but I use the W arguments of open, which tells you I want to open the file in write mode to write in it. And then I create a writer object by using the csv.dictWriter function, which, as the name says, is a helper to write CSV files. and I have to give the names of the fields, so the name of the columns of my CSV file, and then I use the write header function that writes the header of the CSV, and then I write line by line the lines I want. And then the first line that I show here will give you the content of the file. Yeah, it will be better if I run the first line. Okay. And then you see the first line contains the columns animal and toy that I gave here. And then the second contains the values cat and laptop. Cat has been put in the animal column, laptop in the toy column, and then dog in the animal and cat in the yeah, because the dog plays with the cat. Okay, that's funny. Okay, so you see, I've shown you how to read and write CSV files. It's just an example of a module. There are thousands of modules, many modules included in Python, and an enormous amount of them that are not included, but you can easily install, but we will see it later how to do that. Just now, in fact. So the package manager in Python is called pip, and it works in the same way as package managers that you have on Linux distributions, for instance. So you can use pip search, and then the name of the package you are searching for. Here I use Beautiful Soup as an example. It's an HTML parser, so it reads web page. And then you have pip install, which will install the package for you. So there are two ways. Pip install like that will install it for all users. If you use the -- user option, it will install only for you. Now pip is a bit smarter. If you don't have permission to install for everybody, and you don't use the -- user with the recent version, it will install it only for you by default. But those are the two ways. And then if you want, you can upgrade to the latest version with the -- upgrade option. And if you want to remove it, you have the pip uninstall arguments, which will command, which will remove the package. Okay, so that's quite easy. If you need to install, for instance, let's say matplotlib, which is a very nice module package to do plots in Python, you just do pip search matplotlib if you want to know if it's available, and then just pip install matplotlib. And you will have the matplotlib module available immediately after a short installation step, and that's it. Okay, that's easy, and that way you can manage your modules the way you like. But as you saw, you can install easily many modules, but if you have many different projects that use different modules, you will soon get overwhelmed by the number of modules that you have, which are all at the same place, and you can get into troubles. For instance, if one of your projects uses one version of Beautiful Soup and another project needs to use another version for backward compatibility of something. And to avoid this kind of issues, there's a very nice package called virtualenv, which allows you to define environments for each of your projects. So if you do pip install virtualenv, you will get this package. You will only have to do it first, one time, obviously. And then gives you the virtualenv. Oh, sorry, I double-clicked by mistake here. It gives you the virtualenv command. And this command allows you to create an environment. Here I call it my virtualenv. And then to use some script like this to get into this environment. In that environment, whenever you use pip, it will install commands and modules and packages only for this environment, not for the whole system, not for the whole users. It will only be available inside this environment. Okay, so this is quite handy, and all the work you do there, if you do afterwards the deactivate command, then you get out of the virtual environment and you get back to the modules that are installed on your user. So you don't have access to the modules you would have installed inside the virtual environment. You can have as many virtual environments as you want and have different modules in each of them, and they won't know about each other, which is quite convenient. Okay, so each virtual environment will be its own secluded place with its own modules, with their own versions, and they won't talk to each other. Okay, so this is quite convenient. Now a bit about exceptions. So we've seen very early in this presentation that, for instance, if you use a dictionary and you request a key that doesn't exist, there will be an error that appears on Python. This error stops the running of the Python script, and the way it is shown, you see, is called an exception. Okay. Here I show you an example. Sorry. So I have a variable which is default animal. I have a dictionary which is empty. If I try to do my var equals my dict key animal, as the dictionary is empty, it should raise an error. Okay. As I know that from experience that it could raise errors from time to time, I use the try keyword to open a block. Inside, I expect sometimes to have this exception appearing. And then I use the except keyword with the type of error, which is here a key error, to tell the program what it should do when it encounters this error. Okay, so it will try to do this. And if it raises an exception of type key error, then it will do this. Okay. In this case, so if I execute that, it tells me that a key error was raised for key animal. That's what is here. And then it tells me that the key animal is not present because that's what the key error tells me. Okay. So in this case, that way I can handle the errors that I expect to appear from here and there and manage them properly. Here, obviously, the fact that I try to get a key that doesn't exist in the dictionary would be solved in a normal situation with the get method of the dictionary. Okay, we've seen that earlier, but it was an example because this is the only exception we've seen before, so I wanted you to be confident, be comfortable with it. Okay. So that's the basics of exceptions handling. So in Python, the idea is that exceptions are not considered errors. They are considered a normal mechanism and the basic way of handling many different things. And I will show you with an example of why exceptions are a really nice way to handle issues. Here, I want to open many different files and do things. Here it's 2 files, but it could be many more. And I want to open all them and work with the content of all these files. So I import the OS modules, which, among many other things, let me know if a file exists or not. I do an if to check if file1.txt exists. If it exists, I open it. Then if the first file has been opened, then I do an if to know if a second file exists, and then I open it, and so on and so forth. If I had 5 files, then I would have blocks inside blocks inside blocks inside blocks, because I don't want to open a second file if the first one was not opened properly, okay, because I need all of them. You see that it's quite an ugly code because it gets indented very far. It also just checks that the file exists. It doesn't check anything about permissions or anything like that. So it's not efficient. It's ugly and inefficient. The way we would solve that kind of problem with exception is the following. We would write it that way. So here I open files not using the context manager just for the sake of the exercise, but you will see I do a try and then I open both files, and then I catch the exception IO error, which is the exception which is open if the file doesn't exist or if it's not, if you don't have permission to open it, among other things. And then if this error appears, I print some error. And then I have the else keyword that you have here. And this else keyword, the block that is behind is executed only if there are no exceptions. So it's basically the block where you want to put the processing of the key of the files in this case. So here I put the opening of my 2 files into the try block, and if one has an issue, I print some error, and if none have the issue, then I go on with my code. Okay, so if I do that, it tells you input file error, no such file of directory, my file2.csv. That's because I do accept IO error as IO here. So I put the content of the IO error into the variable IO. And then here in my print, I print the result of the error. So you see, in this case, the code is flat. You don't have this indent scale that was ugly before. The error tells you which of the files could not be opened directly. And errors are managed at the same place, so you don't have to check with an if each file is editable. You have permission to go there if it exists and so on. Everything is fine, and then your code will be executed only if there are no errors in a clean way. Okay. So you see in this example, which is a bit exaggerated, obviously it's built for the sake of the exercise. If I had 10 files to open, I can put all of them in the try block. And when I went through this try block and accept an else, I'm sure that every file is opened properly and I can work with that. Okay, so this is one way to show that in Python exceptions are a good way to manage solution instead of if blocks when you would have to put if blocks with many conditions and put if blocks inside other if blocks and so on and so forth. So now I will talk a bit about how to code for the future. It means how to code for yourself. For instance, imagine you're in the first year of your PhD thesis. You write some Python code, and then you work on many other things. I've done a PhD, I know how it works. And then you, on the second year of your PhD or the third year, your advisor comes and say, we have to rework a bit on that, come back on this. And you come back to your old code and you are completely lost because everything has changed. You don't understand what you did. You don't know how to take back from there. So coding for the future is for that situation where you will make a nice gift to yourself of the future by doing a code that is good, that is easy to get back to. It works also if a colleague of yours has to use your code. If your code is done with the idea that someone else or you in the future has to come back to it, then you will gain a lot by taking a few taking a few steps to make it good. Okay. So the first thing is commenting your code properly. That's something you already know from other languages. That's nothing new. But in Python, there's one specific way of doing that, which is really nice. Is that if you define a function or if you define objects in oriented object programming, you can always put a string below the definition, just below the definition, and Python will always use that string as the help string for the object. So if I define my function and I put some help here, I use the pass keyword which just allows me to have an empty block, and then I use the help, oops, sorry, too fast. I use the help function on this function. It will give me here the help that I put there, okay? So if you are in the Python interpreter and you want to know what a function does, this help is already defined for all the Python functions, but there's no reason not to include these two command lines in your own code because it will make your life easier and probably some colleagues sometime will thank you for that, okay? So that's one way of making comments in Python for objects and functions in a way that's easily readable directly from the interpreter. Another way that you can make your code future-proof is to include self-tests. So I know that not all projects are very easy to work with self-tests, but in many cases, when it's a computation, it makes sense. What is self-test is a way to check that a function still returns the expected things and the return keyword. So you have a function here in this case that adds 1 to some value. You see I've added some help. And I want to check that whatever it does, so perhaps this function inside will call other functions, use other modules from other people, and so on and so forth. So things I have no control on. And I want to be sure that this function continues to return exactly what I expect. So what I can do is just write a text file with these 3 lines. So with these symbols, you define the lines that are Python lines. And then if you don't put them, it will be considered an output. And here I say that if I import this +1 function from my file, and then I do +1 on 4, I should expect to have 5. Okay, that's just a text file. When I then do Python -m doctest, so doctest is oh come on, my touchpad double clicks. So if I do Python -m doctest, so doctest is the module which includes this functionality on the text file that I just wrote. It will run the test that I wrote here. And if there's an error, it will tell me the error. Okay, that's the very basic way to do tests in Python. There are other ways. Sorry, I need some water. There are many other ways to do tests in Python, but this is the most basic. And in many cases, it's worth spending the time to define the tests. Even though it takes a bit of time, it will help with the stability on the long term. Another way that you can make things better is to include proper logging into your Python code. So if you have been programming in the past, you are like me, you are debugging, you use a lot of print statements everywhere to know what could go wrong, etc. And then you go in production and you want to remove all those print statements, and then you go around and you comment or even remove those print statements because you won't need them in the future. But then sometimes your code doesn't work, and then you have to put those print statements back again, and you curse because it's stupid to remove and add again the same things all the time. For that, Python includes a very nice module which is called logging, which is a core module, so it's always installed in Python. And what it does, it defines a level of logging that you want, here in this case, warning, and you have lines like this. So a line like this will tell you, it will print the message that is between quotes only if the level is warning or below, okay? So if you put the logging level to info, it will print info, warning, and error levels, typically. And if you put it to debug, it will put debug, info, warning, and error. If you put it to warning, then all levels below, info and debug, will be ignored, and the print will not appear. So you write your code, and whatever you want for debug, you put in the debug level with logging.debug. And then at the top of your program, you put the logging level to warning, and these things will not appear. And if you want to debug your code later, you just change the level. You just change the level to debug, and everything comes back, and you have just changed one place, and everything has come back. Okay, it's really, really useful. One thing to remember is that if the logging level is defined somewhere, you cannot redefine it at another place. It's the initial version of the logging level that you have to change. If you have, for instance, if you import a module which uses the logging level, then it can affect your other modules. Another thing that is important, is not really coding for the future, but it's an important feature, is that any file in Python is a module. So if you have a file called myfile.py that I used already a lot in the past, and if I do import my file, it will take all the, for instance, all the functions and variables into from the myfile.py file and bring them, as we saw with the import syntax, inside the current code. Okay. It's nice, but if you do that, it will do another thing, is that all the code that is written directly into your Python code will be run immediately. Okay, so if you already programmed, you know that in your program you have two things, two parts. First one is definitions of functions, of variables, of objects in object-oriented. And then the second part is the main that you have, for instance, C, which runs the program itself. Okay. In Python, you don't really have that. You don't have a main. But if you import some code, you don't want the main part to run. You only want, most of the time, to import the objects. Okay. And there's a trick to avoid this kind of problems, is to use this line, if name equals main, inside the module that you want to import. So into the my file file, I will put that, and inside this block, I will put what should be executed when I run. This double click is getting me crazy. What should run when I run the code, not when I import it. Okay. And that way, by using this line, if I import my file, this part that is in the block if name equals main will not be called when I import the file. Okay, so it separates nicely your code into the objects you want to import before this block if name equals main block, and the main part that runs that comes after. Okay, it's especially useful if, for instance, your code does long calculation and you don't want to import them, because if you import the calculation, it will take a long time. So you want to exclude that from the import. And then to write good code in Python, you have two sources of good practice. You have the PEP 8 rules, which is a set of rules that how your code should be formatted to be readable, and that allow all users to have a consistent syntax. And then you have the Zen of Python, which you can get by doing import this in Python, or so I thought, because it doesn't appear. Okay, again, something that depends on the Python version. I should really check that. Okay, if you go online and check the Zen of Python, it's a simple set of rules that that allows you to make choices when you have to design your code. It tells you what is better than what else. For instance, explicit is better than implicit is one of the rules, which means it's better if the user which reads your code knows what it does, and not if they have to guess what it does. Basically, there are far more deep meanings to these things, but it's quite of a spiritual way of defining things. Some of these are a bit obscure, but it's quite a nice read, and it will help you decide in some situations. So now, and that's quite the last part of this tutorial before the final exercise, I will tell you about some modules that you can use that are very useful to work. It's not an exhaustive list. It's just a few modules that I use every day. So you know these exist. Obviously, they won't cover all you need, and you will have to go deeper, but this is quite a starting point. So you have the sys module, which allows you to access the arguments of your Python script. For instance, you might want to call Python myfile.py with some additional arguments, and that's provided by the sys module. It also includes sys.exit to quit the current Python script at any point where you need. Then you have, in the same low-level system, you have the OS, which allows you to access the environment variable, navigate the folder structure, so go into a folder and back, create and remove folder, and check the file properties if they are readable, things like that. So that's useful when you interact with the file system. You have glob, which is a very handy tool to get all the files into a folder. So basically, you just glob with a wildcard like star, and you get a list containing all the files that match this wildcard. And then you have argparse, which allows you to build a command line argument system. So I told you about sys argc argv to get the arguments. Argparse allows to build proper help with default values for the arguments and things like that. So it has very professional look. It looks like a normal, it helps you make your script look like any Linux command with help, default values for arguments and things like that. It's really nice. It's a bit more, a bit longer to write, but it's safe and it really has a professional look. Then here I present a few enhanced versions of things that we've already seen. You have, for instance, the itertools modules, which has functions that cycle to run through a sequence ad nauseam. So it runs and runs through, it starts from the start again until you tell it to stop. You have chain to join list or other kind of things that behave like lists. You have compress to filter elements. Then you have collections. Collections is a module that contains elements, objects that behave like dictionaries, for instance, but with additional functionalities, like the default dict. Default dict is a dictionary that in which you define that if a key doesn't exist, then it should be created with some kind of type. It's really useful for not having to check if a key exists or not, and so on and so forth. You can use the get function for that in many cases, but default dict goes a bit further than that. You have ordered dict, this is an ordered dictionary, but since Python 3, I don't remember which, Python 3.6, I think, dictionaries preserve the order in Python, so ordered dict lost a bit of its edge. And then you have some things like counter, which counts occurrence of elements in lists. For instance, if you have a text, it can count the number of occurrence of each character, for instance, just with a one-liner. And then you have RE for regular expressions. If you used regular expression before, you know what it is. If you don't, it's a way to match strings with a very advanced query language to know if it matches with some range of characters, range of words, things that are after or before the things and things like that. And it goes, it replaces the in keywords in more complicated situations. Then in the utilities, you have the copy module, which allows you to copy an object to another. For instance, so we saw that we could do A equals 1, 2, 3, B equals A, and then A and B pointed to the same place. If you do A equals to copy B, B equals copy A, then it creates a new object, and then you don't have this reference system. No, so you have two references to two different objects, and you don't have this problem or this feature, whatever you want, okay? You have time, which allows you to deal with time and date objects. You have pickle. Pickle is quite nice. It can take any object in Python and save it as a string. You can even save it to a file and then retrieve it later. So you can, if you have an object in Python, that's a bit more for object-oriented, but so still, then you can completely save it to a file and get it another way. Or you can transmit it as a string, for instance, if you are working on websites. Then you have JSON, which is really useful to read and write JSON files, which are the basic way you get data from the web. And you have URL-lib, which is now basically replaced by a module called sequences. I should update my slides about that, which allows you to get to some website and get the data there. And you can make requests, you can post forms and things like that online using this kind of utilities. And then to finish now, I will just tell you a little about the difference between Python 2 and Python 3. Now there's basically no reason to work in Python 2. There are still many things in Python 2 around. Some Linux distributions ship Python 2 by default still, so you will see a lot of Python 2 code. So it's important to know the basic difference between the two. So the print function was changed from a keyword to a function. So on the left is Python 2, on the right is Python 3. Okay. The division operator was between two integer was integer division. It has been turned to float division. So that can make a lot of difference, obviously. Then range was a list. Now range is a generator. It's a different type of object. Basically, range doesn't generate all elements for 0 to 9. It just generates the element one by one when you ask them. If you want to do a range of 10 billions, it's far better to have a generator because you won't save 10 billion numbers inside the list. You will just loop over the elements by one without saving the whole thing. And finally, all strings are Unicode in Python 3. This means for basically that you can have special characters in strings in Python 3 without adding additional code. You can have Chinese characters, you can have Cyrillic characters, you can have emojis and anything. It's not cheap in terms of memory, but it's very flexible. And I think that is the last thing I wanted to tell you. And now if you want, you can do this exercise that I suggest you. So normally, if you work on Jupyter Hub, you can have access to files if you navigate to this folder. If you work on the CC clusters, the files are in this place. If you work on your laptop, then you would have to download them. Sorry. And the exercise that I suggest you is to list the files. Then read each file using the CSV module, as we saw before, and read them. So each file contains a UID and one column containing either the name of an animal, the name of a toy, or the name of a house. Okay, so you have 3 files, and one file contains an ID and an animal, then the second one an ID and a toy, and the third one an ID and a house. And then I would like that you build dictionaries like that, with the key being the UID and the content of the 3 files associated to this same UID that are not in the same order, so you cannot use the order of the file, to build all these dictionaries. And then finally, you will be able to write this kind of templates. The animal plays with a toy and lives in the house. Okay, so what I will do is that I will now solve the exercise and explain how to solve it. If you want to work on it, I suggest that you stop following the meeting now. You put it in pause. I think you can put on pause, or you just don't look. I don't know. And then when you have worked on it, and if you need help, then you can listen to my solution to get to understand each step of the problem. Okay. I hope it's okay for you. And I will now start solving this problem for you. So, first, for this solution, I will import 2 modules that I need. You've guessed it, so those are CSV files. I will import the CSV module. And also, since I have to list some files, I will import the globe module. Globe, I said, sorry. Then you will use globe to list all the files, the CSV files. So I will say files equals globe.globe. If you look at the documentation, that's how it works. And it should be called star.csv. And for the sake of this small exercise, I will print the list of the files, hoping it works as expected. And you see here the 4 files. And my file, the CSV, is the file I use for the for the exercises before, but the three that interest us are animals.csv, houses.csv, and toys.csv. What I do is I will just remove, using a list comprehension, my file.csv. Just to make things easier. Okay, and then I have a list that contains exactly what I want. So now I want to read all these files and gather the dictionary. So what I will do, I will use the context manager. So the first one I want to open is animals.csv. Animals, I said. I create a reader, oops, sorry. A reader using this A file. And for row in reader, I will print for you the content of the row. Oops, I did something wrong. Okay. Okay, I should have checked on this computer because things don't work the exact same way. That's bad. Ah, yes, okay, no, that's my mistake. All right. Okay, so if you look at it, you see that I will just put that so that it's easier to understand what's happening. So you see that it prints the dictionaries that are contained in the row with the key animal that contains dog, demogorgon, and so on and so forth, and the UIDs here. But what I want to do is to create a dictionary that will contain all the values. So I will create a dictionary first. I will call it my dict as usual. It's empty at the start. And then for each, I will get the UID equals row UID, and I will convert this as an integer. There's no reason to not do that. And then I will do my dict UID, and that should be a dictionary. If you look at the slide before, I explained that it should be a dictionary. And this dictionary should contain the value animal, and the key animal, and the value should be row. Oops. Row animal. Okay. And to make things nice, I will print my dict at the end, so you will see how it goes. So now you see I have an animal. I have a dictionary. The key 0 contains a dictionary itself with the key animal and the value dog. The key 5 contains animal, demogorgon. And you see it's not nice because there are spaces before, for instance, before demogorgon, there are 2 spaces and it's quite ugly. So what I will do is I will do a small strip here to make it a bit cleaner. Okay, so I've read one file using the context manager. I have made a dict reader to do that. I have iterated on all the rows. For each row, I get the UID by converting the UID row into an integer. And then I create a dictionary which contains the, is there some additional? Okay, thanks Damien for uploading the files. So I create a dictionary which at the moment contains only one key, that is the animal. So if I want to do the next one, I will have to open the next file. Oops, the next one is houses.csv. Then I have to do nearly exactly the same, so I will copy. Sorry, I have copy in the Windows way and not the Linux one. And then what I want to do is to take the dictionary with the same UID and add to this dictionary a key house, and the value will be the value of the house column, still stripped, okay, as we did before. So if I do that, I made a mistake. Yes, because this is H file here. Then you see for the key 0, I have animal dog house, and so on and so forth. Okay, but you immediately realize that this is ugly code because I did twice nearly the same thing. Okay, I open a file, I create a reader, I loop on it, and in this time I create a dictionary, and in this time I update a dictionary, but it looks exactly the same. So what I should do is I should do a loop on all the files to do that for each one. Okay, so how to do that? You see the differences between those things are first the name of the file, and then the name of the key I want to read from the file. So I will create first a data list which contains the pairs of the name of the files and the key that I want to use. Then it's first animals, then it's houses.csv. And then finally, the toys.csv. Okay, and then I want to loop on all this. So for file name, key name, in data, and I forgot to put an equal here, so it's not nice. So there I will loop on the data that I've put above, and for each of these things, the name of the file will put in the file name, and the name of the key that I want to read from the CSV file will be put in the key name. Okay, then obviously I want to do the same things I did before, so all these things are there. I have to indent it properly. And then if there's already a key called UID, if there's not already a key with this UID in the dictionary, I have to create a dictionary. So if not UID in my dict, UID equals a new dictionary, and then I can do what I did before, my dict UID and then the key name was key name dot strip. Okay, that way it will read files. So it's not animals.csv, it's file name here. I hope I did not do any mistake, but this way it will read the 3 files and it will get the results from all. So if you see, the key 0 contains animal, dog, house, toy, bone, animal, demographic, house, upside down, and blah, blah, and so on and so forth. So here, instead of writing 3 times the same code, I gathered everything using some lists. So I said lists were at the basics of Python. You use them for that kind of thing all the time. And all this code was gathered into one single thing, okay? Then you see there's a part that's quite ugly. It's because we have to check if it's the first time we run or not, okay? Because if it's the first time, we have to create all the dictionaries for each of the UIDs. And if it's not the first time, that we don't have. So we saw in the modules one thing that was called default dict in the collections modules, and it's there exactly for that. So I will import that. Sorry, from collections. Import default dict, and then I will redefine my dict equals default dict, and I will say that if for a key there's nothing, it should create a dictionary. And so now if I do that, it will create automatically the dictionaries if I need them for each of the different keys. Okay, and then you see with all that the code has gotten quite small. Basically, all the other algorithmics is there, reading the CSV file properly and so on. All this is done by the CSV module. The handling of the dictionary is done in the default dict, and the handling of the list of files is done by glob. And so the idea was to have some template. So the template was something like the animal is in the toy and lives in the house. And then I can loop on my dictionary. So for so what do I want? So the index are for UID, let's say data. I have already something called data somewhere. That's ugly. So let's call it line in my dict dot items, because I want the key and the values. And I print template dot format, and the arguments will be the dictionary that we call line here, with the double star to make it an argument list. And as you see, you get the dog plays with the bone and lives in the dog house, and so on and so forth here. Okay, we can make it a bit better because we don't need, you see, we don't need the UID. So I can do that, and instead of items, there's some function called values that just give the values by ignoring the keys. Okay, and that's even a bit shorter. And I think with that we have one decent solution. There's even ways to do it shorter, but I think I will stop here. And I hope you learned some things about Python today. And that's it. I think I will stop here. So don't forget to, as Damien said at the beginning, that there's a survey to get your participation certificate, and there's another survey for your satisfaction and your suggestions about this tutorial.